Hi, my name is Kevin Jones, and in this walkthrough, I'll show you how to install the rock-solid knowledge Fido component, and I'll show you how to use it as part of ASP.NET Identity. So this is how we'll do that. The first thing I'll do is create an ASP.NET MVC application that uses ASP.NET Identity. And when we do that, we'll need to change the login behavior of Identity. And to change that behavior, I need to scaffold the identity pages. And that means I need to add the identity pages into our application rather than using them from the DLL they normally supplied in. Once we have that in place, we'll add the Fido support from Rock Solid Knowledge. And initially, that will just use an in-memory database. So what we'll do finally is show how to add migrations to the project, to add the table that the Fido component uses, and then we'll update the Fido component to use that table. And we'll do that using Entity Framework. Okay, so let's get started. So if you've seen any of the other walkthroughs on this site, you'll know that I'm using JetBrains Writer. However, the code we'll see is exactly the same as if the code is written in Visual Studio. So here inside Writer, I'm going to create a new project, and we'll call this project Fido with ASP.NET Identity. It will be a web app type project, an MVC project, and we'll set it up to use individual authentication, which in this case means using ASP.NET Identity. So if I create this, so we end up with a standard ASP.NET Identity project. So before I run this, I want to make one change to how this accepts passwords. So if I look in startup.cs here, when we call add default identity, the only option we configure for the password is sign in require confirmed account equals true. And I'm going to change these options. So here, if I put this into a block, I'm not going to require a confirmed account, and I am going to change the requirements for the password. So just for testing purposes, I'm making our password much simpler. So no digits, no requirement for lowercase or uppercase or unique characters, and no requirement for non-alphanumeric characters, and no required length either. So now if I run this and go to my browser, we see we have the standard ASP.NET Identity pages. If I go to register, I can register an account here with a password, and that will log me in. And if I log out and log back in, we can log in with the same account. So before we get into the code, let me show you the behavior we expect. So here we see a sort of finished version of this. And on here, if I click on the secure link, the application asks me to log in. And if I log in, then it takes me to the page. Now, once I'm logged in, what I can now do is register a Fido device. So I can click on register device, give this device a name. I'm using a YubiKey as my device. Click on submit. I have to authenticate the device. So the device is now registered. Then if I log out and go to secure, it asks me to log in again. So the same as before, except this time, because I have a device registered, I also have to authenticate with that device. And once I've done that, I'm now fully authenticated. So this is where we want to get to. We want to allow the user to log in normally, register a device, and then the next time they log in, if a device has been registered, to use that device to authenticate. So let's write the code to do that. So this is where the Fido component comes into play. We'll use the component both to do registration and both to manage the login using a Fido device. So to use the Fido component, I have to do two things. I first have to install it. So if I go to NuGet and search for rsk.fido, I'll find this rsk.aspnetcore.fido package, and I can add that to my project. Once I have that, in my startup code, I can add a call to services.addFido. This thing takes an options, and in that options, I specify the key I'm going to use for the component. I also specify that I'm using an in-memory store here. And as I said, later on, we'll take a look at using this with Entity Framework. To get a key, you can go to identityserver.com, and from here, go to Products, Fido for ASP.NET. You can purchase the component, or you can get a demo and try this out yourselves. So before we write the code to manage the registration, let's understand how registration will work. So a user who's been authenticated will walk up to the browser, they'll enter the user details, And part of the details in this case could be the name of the device they want to register. Once they've entered that name, we start the registration process at the server. We'll insert the user into the database and start what's known as device registration. This will send a challenge back to the browser. The browser then calls an API called navigator.credentials.create. And this calls something called the authenticator, and this interacts with the Fido device. If that interaction is correct, we'll get back some public key credentials. We send those credentials back to the server, and the server will then finish the registration and insert those credentials into the database. This looks a little more complex than it is. So let's see how we do this in code. Okay, so back in the project, I'm going to add a new controller. Let's call this Fido controller. And this will manage both the device registration and the login we do with that device. So in here, I'm going to add a method called start registration. And this is where the user will start their registration process. So essentially here we return a view, and that view will allow the user to enter the name of the device they wish to register. So inside my views folder, I'll add another directory called Fido. And then from here, I can create the view. And the view will look like this. It'll be a form where we can enter a device name, click on the submit button, and that will send us off to the register action. To hold the device name, we need a model. So in the models folder, I'll add a class called device registration. And this will have a single property, which will be a string, and that'll be the device name. And here I can say @model device registration. Okay, so once I have that, I need to add the register action. So back in the controller, I'll add a register method, and this is where we do the work. And we need to do two things here. We need to initialize the registration process and then get the browser to challenge the device itself. Okay, so to do this, I'm going to add a constructor to my controller. And in this constructor, I'm going to make use of the Fido component. So the Fido component contains a service called Fido Authentication. Let's just call this Fido and add a field called _Fido. And then to start the registration process, I'll do this. I say challenge equals _Fido dot initiate registration. And initiate registration takes two values. It takes the user ID, which is the name of the user. I can get that from user.identity.name, providing the user is authenticated. We'll do that in a moment. And also the name of the device. I can get that from the model. So I can say model.devicename. So here for the user ID, I'm using the user name, but be aware that normally for this, you'd use a value that cannot change. So maybe some GUID that's associated with that user that uniquely identifies that user. So for this, on my start registration, I'm going to add the authorized attribute. So we can only initiate registration if the user is authorized, and then we can get the user's name from the identity. So I need to await on this, and this returns me something of type Fido registration challenge. And if I look in here, it's got things like the user ID, it has something called a user handle, and some other information this uses part of the Fido registration. So once I have this challenge back, I then want to send it back to the browser and get the browser to challenge the device for me with this information. So to do that, I'm going to create a view. And to the view, I'm going to send the challenge, but I'm going to base64 encode the challenge. And again, to base64 DTO is one of the helper methods on the Fido component. And I'll return this call to view here. So let me create this view. So this view essentially consists of JavaScript that we're going to use to challenge the device. And if that challenge is successful, we're going to send the response from that back to the server so the server can finish registering the device. So to do this, we need to get hold of the challenge in a specific format. And the code to do that is here. We need to list the public key types that we support. And that's held as an array here. And if I expand this, these are ordered by preference. We have something called the relying party details. And the relying party ID will be the name of the server that we're running this code on. And in our case, that will just come back as localhost. We create something called a user handle, again in the right format. So again, we're getting the data from the model returned from the Fido registration. We create a user object that holds onto this user ID and the user handle. And then we call navigator.credentials.create. And it's that challenges the device for us. This returns a promise. If that succeeds, we turn the return credentials into a JSON object, and we then send a post back to the server with those details. And the endpoint for this post is complete registration. So if I go back to my controller, I need another endpoint called complete registration. That takes something of type base64 Fido registration response. And in here, we're then going to call complete registration on the component. If this works, we return OK. And if it fails, we just return bad request. So with these in place, I should now be able to register a device. So if I go into my layout CS.HTML and add a new link here for the Fido controller, and the action is going to be start registration. And I'll call this register device. And if I run the code and go to the browser and log in, I can now register the device. So I give the device a name, click on submit. So I get the pop-up from the browser, touch the key, and the device is now registered. So now that we've done that, we can now go ahead and add the code to use the device when we need to be authenticated. So we have the basic login process in place. If we want to extend this to use Fido as well, then we need to amend the login process. And to amend the login process, we have to do what's known as add scaffolding to the application. And basically what that means is we have to add in the UI that ASP.Identity provides for us and edit that UI and edit that behavior. So let's see how we do that. So when we do scaffolding, we're actually going to generate code. And to do that, we need to add the appropriate generators onto our system. So I'm going to do this completely by using the .NET command. If you're running Visual Studio, you can also do this from inside Visual Studio. And Microsoft document how to do this with this page. So in here, it talks about how to scaffold identity projects. It shows how to do this using .NET Core CLI, which is what I'll do. And it also shows how to do this using Visual Studio. So from the CLI, the first thing we have to do is ensure that the appropriate generators are installed. And we do that by running .NET tool install -G for global, and then .NET ASP.NET code generator. And as you can see on my machine, this is already installed. And if I change directory to my project directory, from here, the first thing I have to do is add the appropriate packages into the project that the generated code will use. So this is the set of commands we need to run to add these libraries. And we'll add these one at a time, and we'll do that now. And once we've done that, we can then check to make sure the identity generator is in place by running this command. So basically identity -H, asking for help on this particular generator. And sure enough, we get the help. With that help in place, we can then generate the code. And this is the command to do that. So here we're saying generate identity, use a data context of application DB context. This is the DB context from my application. And as we're running on the Mac here, and I'm using SQLite, then to use the SQLite tools, not the SQL Server generation. So I run this command, the generation is finished. And if I go back and look inside the project, we notice here now inside areas, I have the pages that make up ASP.NET Identity. And ASP.NET Identity is written using Razor pages. So I need to make a couple of changes to get this to work. So inside _layout.cshtml, inside manage, I need to change the base layout page to be views shared layout CSHTML. And one other thing to check is we have this identity hosting startup.cs, and check that in here it hasn't configured the services that we already have configured inside startup.cs. And sure enough, in here it hasn't done that. Okay, so to prove that we're going to use the scaffolding, if I find the login CSHTML page and make a change in here, so at the moment it says use a local account to log in. So let's change this to say use a local account to log in. Rerun the project, go back to the browser, log out, and log back in again. And notice how the text has changed. So we are using the scaffolded pages. So to do this, we need to hook in to the standard ASP.Identity login mechanism. And that mechanism is handled by the Razor pages, and that's why we scaffolded them. And in particular, this page here, login.cshtml. And this page has some code behind, that's login.cshtml.cs. And we can see here there's a method onGetAsync, and that serves up the login page. And then onPostAsync. And onPostAsync is the callback when the user clicks on the login button on the login page. And in here, this does the usual thing. It checks to see if the model state is valid, and if it is, attempts to log the user in. And it does that by calling signInManager.passwordSignInAsync. So we want to hook into this behavior. So we want this behavior to stay exactly the same as it is if the user does not have a device registered. But if the user does have a device registered, then we want this behavior to change so that we force the second factor and force the user to use their Fido key. So to do that, the first thing we will need to do is to check to see if the user has a device registered. And we'll do that after they've signed in. Now, I want to make this code slightly easier to read. So to do that, I'm going to factor out the code inside if model state is valid. So in here, I create a method called doLogon. And this contains essentially the same code from the onPostAsync method. Notice this returns two values. It returns an action result, and that's the action we would take normally at the end of this method. And it returns a sign-in result. And that sign-in result is the result of calling password sign-in async. So inside onPostAsync, I can use this method. So here, if this code was exactly the same as before, I'd call doLogin and then return logon result. And now nothing's changed. But what I'd like to do here is to check to see if the user has a device registered. And if they do, force them to use that device. And if they don't, then just carry on with the normal login process. So to do that, I need to use the Fido component. So the Fido component has another interface I can use called iFidoKeyStore. And I can inject that into this page. So in the constructor, I can say iFidoKeyStore, keystore, bring in the reference, and then assign this to a variable. And then in onPostAsync, I can now change this code to do the appropriate thing. So the first thing I want to do is this. I want to say if not sign-in result dot succeeded. So if the login failed, then return logon result. So if the logon failed, then go and do whatever we should have done on normal failure. If the login succeeded, however, I then want to reach into the key store and call this get credential IDs for user. So a given user may have multiple devices associated for them. So we pass in the email, we're using that as the user ID, and we get back the list of all the registered devices for this user. If this list is null or this list is empty, then there are no registered devices. And in that case, we just do what we would have done normally. Again, we just return logon result and behave as if we knew nothing about Fido. However, if we have a device, then we want to force authentication using that device. So in here, I want to add a few things. To do the login, we have to redirect to the appropriate URL. And that URL is going to be /fido/login. So this will kick off the login process using the device. However, before I do that, I want to make sure I'm signed out of the current scheme. So I'm going to call signInManager.SignOutAsync to force my user to sign out. And the reason for this is that at the moment, the user is signed in. We're now going to redirect and do the two-factor authentication. If that authentication fails for some reason, the user is still signed in using the default scheme. So I've forced them to sign out of the default scheme and then redirect. And if the Fido authentication succeeds, I'll sign them back in to the default scheme. However, when the user hits this Fido login page, I still want to check to see if they're authorized in some way. So what I'll do here is I'll sign them in using a different scheme. So I sign them in using this two-factor user ID scheme. And then inside the Fido controller, when we hit the Fido login endpoint, I'll check to make sure they're signed in to this scheme. As part of this sign-in, I'm going to create a new claims principal. And inside here, I'm going to pass in some claims for them to use. And the claims I'm going to pass in are the email and the remember me flag. And the reason for that is that we'll need these values when we do a sign-in. I'm calling a method here called build claims. And build claims looks like this. So it creates a new list of claims and it adds the username and remember me claims to that list and returns that list. And I then include that list of claims inside this new claims principal before I redirect. So over in the Fido controller, we have to add the login endpoint. And that endpoint will look like this. So it's an async method called login that returns an iAction result. So inside here, the first thing I want to do is to call authenticate async on the two-factor user ID scheme. And remember, we've just logged in using this scheme on the login CS.HTML CS page. So if this login is successful, I want to start the Fido authentication. However, if I'm not authenticated here, then I'm going to redirect off to some error page. So what do we do on successful login? So I need to initiate the Fido authentication. And I do that by calling initiate authentication through the Fido component. And to initiate the authentication, I need the username. Remember, we've registered the key, we've given the key a name, and we've registered that key against a user. So to get that username, I'm going to use the claims that I stored when I logged in using this two-factor user ID scheme. So I can reach into the result I get back from authenticate async, take the principal and the claims, and then call first or default on this, asking for the username. This will give me back a value, which may be null, in which case the initial authentication will fail, or it will give me back my user ID. And again, initial authentication, if the username is correct, will succeed. And if it's not, again, it will fail with some error. Once I've started the authentication, I then need to go back to the browser and get the browser to challenge the device for me. And I'm going to do that in this case, in a similar way we do it with registration. I'm going to return a view, and to that view, I'm going to pass in this challenge object. So for this view, I need to build a CS.HTML page, and that page is going to be called login.CS.HTML. And that page looks like this. So the model is my base64 Fido authentication challenge that we're passing down from the server. The view itself, just like the registration, is mostly JavaScript. We're taking various values of this model, such as the challenge and the relying party ID and some keys. We're converting those to the correct format. And then we call navigator.credentials.get. This call interacts with the authenticator through the browser. I have a YubiKey, so in my case, it'll ask me to touch the key. I touch the key, and we get back the result of this call. At that point, I then post that result off to my complete login endpoint. So I'm using jQuery here, I'm using its AJAX call, and I'm posting this data up to Fido complete login. And again, that's inside the Fido controller. So inside here, I need another endpoint. So the method will be called complete login. And this takes something of type base64 Fido authentication response. And this is the data in encoded result that we're passing back from the browser. So inside this method, I want to do a few things. I want to call complete authentication on the Fido component. And then if that succeeds, I want to re-authenticate using the default scheme. And to do that, I'll need the sign-in manager. So on this controller, I'm going to change the constructor so that it takes a sign-in manager of type identity user. I'm going to assign this to a variable. And I'll also need a user manager. So I add that here. So that'll be a user manager, also of type identity user. And we'll call that user manager. And we'll also assign that to a variable. Okay, so in here, I need to re-sign in. And to do that, I need to do a couple of things. I need to see, first of all, if this user exists. And I'm going to do that by calling usermanager.findByNameAsync, passing a username. And we'll see where we get that username from in a moment. Once I have that, I can then call sign-in manager sign-in async using the user we've just found and this remember me flag. So where do we get the username and the remember me flag from? Well, they come from the claims we set on this user using the two-factor user ID scheme. So in here, I need to call authenticate async on that scheme. I'm not going to check the result here. I'm going to assume this succeeds. And then once I have that, I can get the claims. And then from those claims, I can extract the Remember Me claim and the username, and I turn the Remember Me claim into a Boolean from a string. So now we've signed back in using the default scheme, and the user should be authenticated. Regardless of whether the call to complete authentication succeeds on the Fido component, I want to call signout async on this two-factor user ID scheme. So if the authentication was a success, then we sign out, and if it's a failure, we sign out and go back around and try and authenticate again. And then to finish up, if there's an error, I just return bad request, and if everything has worked, I return OK. And then inside this page, if everything has succeeded, I'm going to redirect off to / URL. If anything has failed, I'm just going to print an error on the console. So I want to add a couple more things to show how this works. So the first thing I'm going to do is to change the home page. So in index.cshtml, I'm going to list out all of the claims that have been added to my authenticated user. And we should see the set of standard claims that we'd get from a standard ASP.Identity authentication process. I'm also in the home controller going to add an authorize attribute to the privacy endpoint. So now when we click on that endpoint, we need to be authenticated before we can see this page. Okay, so now that we have this, we can run the application, register the device, and then when we log in, we should be asked to authenticate using two-factor authentication. So if I run the process and go to the browser, we're currently unauthenticated. If I log in, so there's no device registered. I notice we get a list of claims. I register my device. If I log out and log back in again, it asks me to use the device. I'm now re-authenticated and I still get the list of claims. So we've logged back in using the original scheme. And again, if I log out and click on privacy, and remember we set this now to be authorized, I'm asked to log in, use the authenticator, go back to the privacy page, and sure enough, we now have access to that page. So at the moment, if we restart the server, the information about any device we've registered is lost. And that's because we're using an in-memory store. The Fido component also comes with an entity framework store, and we can use that to persist registration information. So to use Entity Framework, the first thing we need to do is to be able to run the migrations. And we obviously run the migrations to create the database. So to do that, rather than do that in this project, within this solution, I'll add a new project just to manage the migrations. So for this, we'll add an empty web application, and I'll just call this migrations. Okay, so inside here, we need to change our startup code. And the first thing I want to do is to add a constructor, and that constructor will take an configuration that we're going to use later. And I'll add a configuration property to keep hold of that reference. So we'll do the work of managing the migrations inside our configure services. So inside here, we'll add a call to get the connection string to use. And we've called that DB here. And we place that connection string inside app settings. And the data source of this, we point at the application database, which is in the other project within this solution. So that's basically up one directory from where we are, and then into the Fido with ASP.Identity, and then the app.db SQLite database that's in here. So once I have that, I then need to call services.addAuthentication, which seems weird, but this registers a service that we need. It registers the system time service that is used within the component. So we need to add the appropriate packages to the application. So if I go to the NuGet tab, we have the RSK ASP.NET Core Fido Entity Framework package. And if I add that, then inside services, I can call add entity framework store, which is an extension method provided by the Fido component. I want to use SQLite. To use SQLite, again, we need to add the appropriate package. So if I go into NuGet, and I can add Microsoft Entity Framework Core.SQLite to this project, and now bring in that reference. I also need to add the Microsoft Entity Framework Core design package. So again, we add that to the project. As far as the configure method is concerned, we don't need any code in here as we're never going to run this as a web application. So once I have that, I can build it. And once it's built, I can run it from the terminal. So I'm in the appropriate directory here. And the command I want to run is this. So I want to run .NET EF migrations. We're adding migration. It'll be called Fido. We're specifying a DB context here, and I'll show you where we get that name from in a moment, and we're telling it what the output location is. So where do we get that DB context from? So if I look back in the code and look at the code behind Add-Entity Framework Store, we can see this code as a DB context uses this Fido DB context. And Fido DB context, again, is just part of the component. So if I go back to the terminal and run the command, we'll get the creations. We can also run another command to create the SQL for this migration. And if I look back in the project, we have a migrations folder that contains the migrations code and the generated SQL for that migration, which is SQLite specific. And then we can run the command to update the database. And that will apply the migration to the database for us. So what we can now do is back in the project, go back to the main project, back to startup. And rather than using the in-memory store, we can change this to use the entity framework store. Before we do that, we have to add the entity framework package. And then rather than calling add in-memory key store, we call add entity framework key store. And as we did in the migrations project, we need to define the connection string. This time this is defined using the name default connection. So rather than DB here, we say default connection to get the connection string. And we can also leave off the migrations as that's done in a separate project. So with that in place, if I rerun the application, so then from here, we can log in. We can now register our device, and now it'll be registered in the entity framework store. So if I log back out, log back in, we're asked to use the device and we're authenticated. And if I go back and restart the application, and remember when we did this before, it forgot the device registration. If I go back to the browser, go to the home page where I'm now unauthenticated, log in, it asks me to use the device. So it's remembered the registration. And again, we're authenticated with my name. And just one last thing here. If I take app.db and drag it into the database window, in here we'll find a table called Fido keys. And if I run select star from Fido keys, this is the registered key. I notice this registers Kevin at rocksolidknowledge.com and the display name is now UB. So now we're using the entity framework store rather than the in-memory store to manage the keys.